Okay, here's question 3 on assignment 3.2, just to use as an example, kind of help you out. Okay, so first of all, okay, we have our balanced chemical equation. They give you that in the as part of your question. Okay, it also says that you have 1 mole of each of like all the different chemicals are mixed in a 4-liter container, and then the following equilibrium happens. So you have 1 mole of each of these. Okay, and then again, concentration equals N over V. And so it's the same for all of them. You have 1 mole of each of them. And then you have a 4-liter container. Yeah, 4-liter container. So your concentration for all of these is going to be 0.25 moles per liter. Okay, so we'll set up an ice table. I'll do that. Okay, so there's our ice table. Now we'll start filling it in. So we have our initial concentration for all 4 things is 0.25. Okay, so that's where we're going to start. And then again, now for our change, we're going to, for the reactants, they're going to produce products. So we're going to go minus the coefficient, so minus 4 times x is the change. This one is minus 5x. This, now the products we're going to add to that, so we're going to have plus 4x and plus 6x. And so at equilibrium, our formula is we just write down what we have here, 0.25 minus 4x, 0.25 minus 5x, 0.25 plus 4x, and 0.25 plus 6x. Okay, so that's really what our ice table does, is just lets us find these equations. Okay, now it also tells us that at equilibrium, there is still 0.8 moles of ammonia remaining. So we have, at equilibrium, I'll just write it here, we have 0.80 moles. Okay, so again, we want to find concentration. So it's still in a 4-liter flask, so we're going to go 0.80 moles divided by 4 liters. Okay, and so we get our concentration is equal to 0.20 moles per liter. Okay, so that's our concentration of ammonia at equilibrium, which is equal to this equation. So now we can solve for x, and then once we know x, we can solve, like we can substitute x in for all of these different equations. Okay, so we have 0.25 minus 4x is equal to 0.20. So that's our equation that we're going to use to solve for x. So we'll add or subtract minus 0.25 from both sides. Okay, so that crosses off with that. So we got negative 4x is equal to negative 0.05. Okay, now to get x on its own, we'll divide both sides by minus 4. Okay, which then that cancels with that, that. So we got x is equal to, and we get 0.0125. Okay, so that's our x value. So now we can kind of put in, so at equilibrium, we know this is equal to 0.20. Okay, this, now we just substitute, so 0.25 minus 5 times, and we'll insert our x value, 0.0125. So this is going to equal 0. We'll just say 19, we'll round it. Okay, this one's going to equal the same, or sorry, plus 2. So we have to, we'll do that calculation. So 0.25 plus 4 times 0.0125. Okay, so we get 0.3. And then this one, we got 0.325. Okay, now we have all our values at equilibrium. So now we need our equilibrium equation. So our Kc will equal, so products, so NO, and then the coefficients to the power. So we have concentration of NO times concentration of H2O raised to the power of their coefficient, divided by our product or reactants. So we have NH3, the concentration of NH3 at equilibrium raised to the power 4 times the concentration of O2 raised to the power 5. Okay, now we just put our numbers in. So we got 0.30 to the power of 4, 0.325 to the power of 6, 0.20 to the power of 4, and 0.1875 to the power of 5. And our Kc value that we solve for should be 26. Okay, so the big thing, make sure get your values in concentration. Okay, they should always give you the size of the flask that's in. That's going to be the liters you divide by. Then solve, you should be given these, and if you aren't given these, that means they're usually 0, because usually you don't have any products. In this case, you had they put all 4 things in. Then figure out how much. So products will always be minus the coefficient times x. So minus coefficient times x. The products will always be plus the coefficient times x. And then if you're given one of these values, so we are given it here, well, we're given this value, the 0.8, then we can use that to solve for x. Once we have x, we can solve for using these equations for every other value at equilibrium and put them into our equilibrium equation. Okay, the other things, types of questions, like question 4, you're kind of working backwards. You're given the Kc value, so you're given this value, but then you aren't given, or you're going to use it to kind of solve for one of these values here. Okay, remember for those ones too, you can use the rule of 1,000. Actually, I don't think we have to use the rule of 1,000 for these. But okay, let me know if you have any more questions, anything else you want to see done. Okay, I'm happy to do these examples and make these videos as much as you need.